Hello students, today we are continuing our conversation about heat load calculations and doing a couple examples that are more involved. This house is built on a location with a design temperature difference of 75 degrees, and the room shown is a corner room on the second story, so it only loses heat through these out two walls and the windows, and then also the ceiling. So when we go to do our calculations, I said good advice is to always do the windows first. And we need to find the area of the windows. And because these examples we're going to be doing today have feet and inches, we are going to use a little cheat sheet that we made a couple weeks ago. If you remember the cheat sheet, let me try to go back to it here and show you. This cheat sheet that told us that 1 inch is 0.08 feet, 2 inches is 0.17 feet, 3 inches, and so on and so on. So then we have this example down here at the bottom that 9 feet 10 inches would be 9.83. So if we're looking at our examples here, our problem here, 3 feet 3 inches, and using that little cheat sheet, this would be 3.25. And 4 feet 2 inches would be 4.17. And the same thing over here. These windows would be the same size. That little cheat sheet helps us because we don't have to do those calculations all the time over and over again. So the area of a window would be, the area of the window would be 3.25 times 4.17, and there's two windows that are exactly the same. So 4.17 times 3.25 times 2 means that our windows are 27.105, and this would be feet squared. So the heat load for those windows would be your area times the coefficient of change. Our area is 27.105. and times the coefficient of change. Our windows were single pane windows, and we were in a 75 degree temperature difference. So 75 is this third column over here, and we're single pane, so our coefficient is 110. So we would multiply this by 110. So the heat load for that would be 2,981.55 BTUs per hour for our windows. So now let's look at our walls. The walls, there's an easy way to do the walls. We could do each wall separate. But if you imagine that those walls are on a hinge on the corner, and we flatten this out so that this whole length would be flattened out, and then we could take it times 8. So the whole length would be 11 feet and 10 feet 3 inches all put together. So I'm hoping that you guys can see that this would be 21. The whole length of that would be 21 feet, and 0.3 would be 0.25 off of our little chart. So if we were going to find the area of the whole wall, of both of the walls together, we would take 21.25 and multiply it by 8. So we get 170 feet squared. But remember, the walls and the windows are made of different material, so we have to go back here and take this area of our windows and subtract it off the area of our walls. Because we want just the wall itself. So 142.895 feet squared. So that's the area of just the walls themselves. So let's do the heat load for the walls. The heat load, you take your area, 142.895, and we multiply it by the heat load coefficient. So these walls are wood frame with sheathing 3.5 inches of insulation. So let's go back here. 3.5 inches of insulation. And remember, we're still working with 75 degrees, so our coefficient is 5. So we're going to multiply the area by 5 to get 714.475 BTUs per hour. Okay, the last thing that is losing heat in this room is the ceiling. So the ceiling, we have to think about how, imagine yourself standing in this corner room, and that it would be 11 feet on one side and 10 feet 3 inches on the other side, and you look straight up and the ceiling would be the same measurements. So for the ceiling, should have read a little bit smaller, I'm running out of space. For the ceiling, our area is going to be our 11 feet and our 10 feet 3 inches, and remember I'm using a little cheat sheet to say that's 10.25. So the area of my ceiling is 112.75 feet squared. And to do the heat load for the ceiling, I take the area and I multiply it by the coefficient. This ceiling says that it has 6 inches of insulation. So let's go back to our table and look at a ceiling. 6 inches of insulation. We're still with 75, so our coefficient is 4. So we're multiplying our area times 4 to get 451 BTUs per hour. To find the total heat load for that whole room, we would add all of the individual, for this, the window, the wall, and the ceiling, we're going to add all of those together. To get a total of 4,147 BTUs per hour. And at this point, I can actually round that to a whole number. It comes out to a decimal, but the whole number would be good enough for me to use that measurement to pick out a heating or cooling system for this room. Okay, I would like you guys to go ahead and try the question that's on the Google quiz. Make sure you follow the directions. Make sure you put your name on it. Make sure that you hit submit and turn in. And I hope to see you soon. If you have any questions, please email me at cjones@ictc.edu. All right? Thank you guys. Have a great day. Bye.